Hey, what's up? Welcome back. Patrick here from All Things Mathematics. And moving on to the next question, another time value of money question. So this one is going to be interesting. So a bank pays 6% compounded monthly on all deposits. Every 3 years, it gives a bonus of 1.2% on the balance. What is the effective annual return over 2 years, 3 years, and 8 years? So I'm going to show this question in two different ways. So the first way is going to be a little bit longer. I'm going to actually bring in like a dollar amount so you could see what's happening, but it's more intuitive in solving for this annual effective annual return. It doesn't take too much longer of time, but just easier and more intuitive to explain. But then at the end, I'll show you how you can set up a quick equation and solve for that in order to get the same R value. So first thing is that it's saying that every 3 years you're getting this bonus of 1.2% on whatever you have in the account. So notice that in part A, we're not going to have to worry about this 1.2% because it's happening every 3 years. And because in part A, we're just doing 2 years, right? We're not going to get that bonus. However, for part B and C, we're going to have to incorporate that 1.2%, right? Because in part B, they're asking if you have the account for 3 years, well, you're going to get that bonus at the end of the 3 years. And then in part C, they're doing it for 8 years, so you're actually going to get that bonus twice, right? At the 3-year mark and the 6-year mark. Okay, but we'll get to those. For now, let's just do part A. So what's going to be the effective annual return over 2 years? So what I'm going to do is let's pretend right now in time 0, you deposit $100 into this bank, right? And so what we're first going to find out is what's the dollar amount that we are going to have at the 2-year mark. So what's going to be the future value in 2 years of this 100? What is it going to grow to? So let's first figure that out, and then the second step will be what's the effective annual return that we had over that 2-year mark. Now with compound interest, if you remember, this is the future value formula here, and then this M here represents the number of compounding periods in 1 year, and then T represents the number of years, right? So the M in this case, because this 6% is compounded monthly, right, then we know that in this case our M value is going to be 12. There's going to be 12 compounding periods in a year. Okay, so basically the future value in 2 years is going to be the $100 that we're depositing today, 1 plus, we're going to take the 0.06, divide it by 12, right, because it's compounded monthly, and then we'll have that M value of 12 in the exponent, and also the number of years. Well, we're looking for the future value in 2 years, like that, right? So this would be the equation to get the future value. And when you do this calculation, you're going to end up with $112.72. So that's what you're going to have at this 2-year mark. So what I'm going to do is I'm actually going to erase this here, and then let's bring this amount, okay, 112.72. I'm just going to write it, yeah, let's just write it up here. So it's basically going to be 112.72, right? So now what they want is what's the effective annual return that you're making to get to this amount. So basically you're earning some kind of R percentage here and some kind of R percentage here. And so what we could do is we could just set this up as 100, what rate to the power of 2 would give us this 112.72, like that. And so then that R right here is going to be basically the effective annual return, right, over the 2 years. So what rate, what effective annual rate do we have to earn over 2 years for this 100 to grow or to future value to this 112.72? Okay, so what we would do at this point is divide both sides by 100, and so we'll have 1 plus R to the power of 2 is equal to 1.1272. And then what we could do to bring this exponent over, we could just take both sides to the reciprocal of that exponent, 1/2, right? Or square root both sides. But if this was like 3, this would be 1/3. We take both sides to the power 1/3. So I'm just going to keep it general for now. So we'll have basically, over here, notice the 2's cancel out. So we're just left with the 1 plus r. And we brought that exponent over like that. And so then when you do the algebra here, you bring the 1 over, solve for r, you'd end up getting 0.0617 or 6.17%, right? So that's the answer for part A. Now, that's the longer way to do it, right? So to actually start with an amount, find the future value based on these percentages here, and then find what's that effective annual rate on average that gets you from here to here. Now, if you wanted to set up like a quicker equation, so for example, if I got this on a test. Quick little intermission here, wanted to mention a few things quickly and we'll get right back into the question. First off, if you are getting value from this video, if you can please like the video and subscribe to my channel, it does help me out a lot. Number two, if you're watching this on YouTube, you can go to the description box and there is a link that will take you to my website, allthingsmathematics.com, where all my courses are organized so you can watch the videos in order. For lots of the courses, at the end of the chapters, you can find tests that you can practice with, and the tests have video solutions as well. Number three, if you feel like you need personalized help in tutoring, give me a shout. I currently tutor students 7 days a week over Zoom, both high school and university students, one-on-one and in groups. You can text me. My contact details are on my website. And lastly, feel free to forward the website to any of your friends who are also taking the course, who you feel can benefit from these videos as well. Hit me up on all my socials. It's All Things Mathematics for all of them. Back to the video we go. What I would set up is you just have to look at the compound factor. So what you can do is you can just say, okay, well, I'm going to earn 6% compounded monthly, and then the exponent stays the same, right? So we're still going to have the 12 compounding periods, and then for the 2 years, like that. And then we just have to make whatever this is going to be, right, equal to the 1 plus r, our effective annual return to the power 2. Because basically an effective annual return, the compounding period for that is 1. So if we were to use the same formula here, it's like putting this r over 1 and then having a 1 here. Okay, but that's kind of like what's going on in the background. It's kind of invisible, but because you're just dealing with an effective annual return, right, that's not compounded, right? There's no compounding periods. The compounding period is just 1. And so that's why we're just writing the 1 plus r to the power 2. It's why we did it in the previous method as well when we had the $100, the 112.72. So that's basically what's going on. So again, if you wanted to set up just a quick equation on how to solve this, this is how you would set it up here. It's just a little tougher to explain. But if you understand setting it up like this, then you can just do the math here, right? You would end up just doing all this math and then square root both sides, bring the 1 over, you'd get the same R value of 6.17%. If you did it this way. So this is the quick way to set it up. But again, I just wanted to kind of show it in a bit of a longer way so you intuitively understand what's happening of how taking this 100, growing it to that. So then on average, what's the effective annual return that we earned over the 2 years, right? To get from that 100 to that 112.72 at the 2-year mark. So now moving on to part B, they're asking what is the effective annual return over 3 years. So again, first I'm going to do it the longer way. Let's pretend that we are investing $100 today in time 0, and then let's figure out what we're going to have after 3 years. So Same sort of deal. We're going to take the 100 and we're going to have to future value it 3 years at this 6% compounded monthly. So that would be basically 100. And then we're going to take the 6% divided by 12. And then we're going to have 12, but in this case, it's going to be times 3 for 3 years. Right, so that's going to give us a certain amount here. And when you do it, you end up getting $119.67. However, remember, that's only with the 6%. We're also told that every 3 years, you get a bonus of 1.2% on the balance. So we also have to incorporate the bonus that we're going to get, right? So we have a balance now at the 3-year mark of $119.67, and then we're also getting this bonus of 1.2%. So we're just going to multiply this. We're going to grow this amount by 1.2% by multiplying it by 1 plus 0.012. And when you do that calculation, you end up getting $121.11. So after this 6% earning compounded monthly every year, and then after the bonus of 1.2% on the balance, we end up having $121.11 after the 3-year mark. So exactly like we did before, so let me erase some stuff here. Let's get some room. What we want to do is find out what is that average rate that we are earning. Right? So basically, we're trying to find out, okay, well, to get from 100 to 121, what was the rate for the 3 years on average that we earned every year? So we would just simply set it up like we did before. We take the 100, at what rate would this 100 have to grow by every year for 3 years in order to get to this $121.11. And when you end up doing the algebra, so first dividing both sides by 100, bringing this 100 over here, and then to take this exponent 3 to the other side, you have to take the other side to the power of the reciprocal, right? Or taking like the third root of both sides in order for this 3 to go away. So you got 1 plus r left, and then taking that to the power 1 over 3, then bring the 1 over. After all that calculation, you end up getting 0.0659 or 6.59%. And again, this is the longer way to do it, right? So pretending like you're investing $100, what are you going to have at the end of 3 years with these parameters here, with the interest rate, with the bonus, and then figuring out on average what you made every year in order to get to that. Now, if you wanted to do it the quick way, like just want to have one formula without having this 100 and doing all these in-between calculations, you could just pretty much set up something like this. You could say, okay, well, I'm going to earn this 6% compounded monthly, and that's going to be to the power of 36, right? The 12 times the 3 years. And then I'm also going to earn the, let me write it bigger here. I'm also going to earn the bonus, like that. And then we would make this equal to 1 plus r to the power of 3, right? And then we would solve for r. So you would do this whole entire calculation on the left side, take both sides to the power 1 over 3, or the third root of both sides, then bring the 1 over, you would notice you'd get the same answer, 6.59%. Right? So if you just wanted to set it up in one line, in one equation, without doing all the preliminary steps with first doing the rate and then doing the bonus separately and then doing this calculation, this is a quick equation that you could set up in order to solve for the r in order to get the same r value. Now moving on to part C, and I'm actually going to piggyback our results from part B, because now in part C what they're asking us for is the future value, or sorry, they're asking us for the effective annual return over 8 years. But again, first I'm going to do it the longer way, and then at the end I'll show you the shorter way of how you could set it up as one equation. But what we're going to do again is try to figure out, okay, if we invest $100 at time 0, what's it going to be worth in time 8? Well, we already know what it's going to be worth in time 3, right? That's not going to change. So I'm going to use that amount that we found in part B, and then I'm just going to take it from there, from time 3. Now, we can't just go from time 3 directly to time 8, future value it at this 6%, because remember, it's every 3 years. There's a bonus of 1.2% given on whatever the balance is at that time. So the first bonus was given at the 3-year mark, while the second bonus, it's every 3 years, it's going to be given at the 6-year mark, right? So what we're going to have to do is we're going to have to find how much did this $121.11 grow to up until time 6 at the 6% compounded monthly. And then on that balance, we are going to give a bonus of 1.2%. So that balance is going to grow at time 6 by 1.2%. And then we're going to take that balance and then future value it by 2 years from time 6 to time 8. And then we don't have to worry about a third bonus because the third bonus would have happened in time 9, right? Because it's every 3 years. So after year 6, it would have been in year 9, right? But because we're looking for the return at time 8, right? Time 9 is after, we don't have to worry about that. But we do have to worry about the bonus that is going to be given at time 6. So what we're going to do is let's find the future value at time 6. So we're starting at this 121 and 11 at time 3. And what's going to happen is we are going to future value that by 3 years, right? So again, 6% compounded monthly. And then we're going to have M, the number of compounding periods, times 3, right? From year 3 to year 6, that's going to be 3 years. And so when you do that calculation, you'd end up with $144.93. So that's going to be the balance at time 6. But now what we have to do is add the bonus. So I'm going to say the future value at time 6 with the bonus is going to be this 144 that we have. And then we are just going to grow that by 1.2%, like that. And so that amount after the bonus is going to be $146.67, right? So that's what we're going to have here, 146.67 at time 6. And then what we have to do is finally find out what's that future value going to be at time 8, right? So we're going to take this amount. So the future value at time 8 is going to be this 146.67. And we are going to grow that at the 6% compounded monthly number of compounding periods, but this is going to be for 2 years now, right? So the exponent's going to be 24. 24 months from 6 times 6 to time 8, right? This is 2 years here. So that t value is 2. And when you do that calculation, you're going to end up with $165.32, right? So that's what your balance is going to be at the 8-year mark. And again, you're not getting a bonus of that because the next bonus would have happened at the time 9 mark, right? Every 3 years. And so now we can find the effective annual return over this 8 years because we have what we started with, the present value 100, and then we have the future value that we're going to end up with 165.32, right? So we're starting at 100. What rate over 8 years did we earn to get to this 165.32, like that? And then you would solve for R, right? So you could think about this R that we're solving. It's kind of like an average. What was the average rate that we earn over all this time? Because notice that we're mixing a lot of rates, right? We got this 6% that's compounded monthly, and then we got this 1.2% of bonus that's happening every 3 years, right? So there's a lot of rates, different rates going on here, different compounding frequencies, etc. So after we get that future value amount, what they're asking for is basically, well, what was the average over the 8 years? That's how you could think about it. And so then you just have to solve for this R, right? So you'd have 1 plus R to the power of 8 bring the 100 over, so we would divide the 165.32, divide it by 100. Then if I'm bringing this 8 over, it would be like, you know what, don't even have to put the brackets because this 8's going to come over, so meaning that we got to take the 8th root of both sides. So we would take this 165.32 divided by 100 to the power of 1 over 8, like that. And then you would bring basically the 1 over, right? So you'd have 165.32 divided by 100 to the power of 1 over 8, and then we're going to be subtracting 1. And so when you do that calculation, we end up getting this R value of 0.0648 or 6.48%, right? So that is the answer for part C. Now, what if you wanted to set this up as just one equation, so we don't have to think in these kind of interval terms with, okay, the bonus happened here, then the bonus happened here, etc. What if you just wanted to write one equation, just one line, in order to solve for this R value? So what we would do is, okay, let's go in order. So for the first 3 years, you are going to earn that 6% compounded monthly, right? So that's going to be 3 times 12. That's going to be to the power of 36. Then you're going to earn that bonus at the 3-year mark. And then you're going to have to future value it again from the year 3 mark to the year 6 mark. So that's going to be to the power of 36 again, right? 12 times 3. Then you're going to get another bonus like that at the year 6 mark, right? And then you're going to future value it from time 6 to time 8. So we would go take the 6% compounded monthly, and that's going to go to the power of 24, right? 12 times 2, like that. So then all of that is equal to 1 plus R to the power of 8, and then you would solve for R, right? You would do this entire calculation. On the left side, take both the 8th root of both sides, or this side to the power of 1 over 8, bring the 1 over, you should get this same value. And actually, if you notice, there's actually like terms here. So the way I wrote it out here, this long way, it's kind of just, I wanted to show you sequentially what happens, right? This is from year 0 to year 3, then the bonus, then year 3 to year 6, then the bonus, then from year 6 to year 8, right? But notice that we could actually combine these here, right? These are like terms. They have the same base, so we could add the exponents. So you could actually make this equation shorter. You could divide this by 12, and then this would be what, 72 plus 24, which is what, 96, right? And then this and this, right? This is to the power 1, this is to the power 1. They have the same base, so you can add the exponents and take it to the power of 2 and make that equal to 1 plus R to the power of 8. So you could even make a shorter equation. However, I didn't want to start with this right here because then it's tougher to explain. I wanted to show you sequentially first what happens, but technically this is a shorter equation that you can make here because of the like terms, right? Because of the bases, the exponential expressions that have the same base, you could add the exponents for the 2 different bases and then solve this, you'd get the same R value. So whichever way you do it, answer for part C is 6.48%. And that's a wrap for the video. Hopefully you enjoyed that. If you want to see more videos like this, please go to my website, allthingsmathematics.com. Over there, all of the videos are organized by chapter, by section. If you feel like you need tutoring at any point, you could also hit me up. My contact details are on the website. Enjoy your day, and I'll see you in the next one. Peace out.